Hey, everybody, this is Larry. This is Biweekly Contest 26. Um, yeah, this is live, so let's get it going. Hit the like button, hit the subscribe button. Wish me a little bit of good luck or a lot of good luck. How did you do? Did you find the contest easy? Did you find the contest hard? Leave it in the comments below. Just let me know, and we'll chat about it or something. I don't know. But yeah, what's there else to do? I don't know. All right, gonna try to do a 10-second meditation. Uh, Breathe in, breathe out, and let's get started in here. Here we go. All right, let's go. First problem, consecutive characters. So yeah, this seems pretty straightforward. Even reading it, I was just making sure the way they phrased this problem was a little bit odd. So I was just like double checking that um, that I understood it. Um, but otherwise, it was straightforward. And I was like, okay, let's crank it out. Basically, you just keep track of how many consecutive characters you get, and then you take the max of that. Um, Things that I guess I've done this enough times because I basically use Python zip, which allows me to look at adjacent characters one at a time. And yeah, I was just double checking or thinking about the count is equal to 1 or it should be equal to 0. But yeah, and also I have to reset if it's not the same. And then that's pretty much it. I think I submit right after this. So cool. I was so careful. Q2, simplified fractions. So yeah, so this one you just have to generate or have a way to generate all the simplified fractions. The key thing to note is that a fraction is simplified if they don't have a common denominator. So basically, which means you just use the GCD function to check whether, and because n is equal to 100, you could generate all 100 square pairs, or 100 choose 2 pairs, if you will. And and then just make sure that yeah, the GCD fits and the numerator is smaller than the denominator, and then that's it. I think I just played around off by ones here, but that's the general idea of behind what I had to do. I was thinking like, do I need enough, or like, is it n or n plus one or something like that? And I took a little bit more time to think about the actual edge cases, but then I was like, whatever, just we could generate it, or we can filter it out later or something like that. So yeah, that's essentially what I did. It's pretty brute forcey, but it's Q2, so I was confident about it. Though it was at this point it is wrong, but because I had to convert it to strings. And also at that point, even though that wasn't part of the thing, I realized that I should make sure that y is bigger. Yeah, y is bigger than x. And I was like, oh, that doesn't include one of the numbers, so I need m off by 1. And I didn't need it on the x. I was thinking about it, but I was like, yeah, just do it anyway. Because GCD would never be equal to 1 on n, but that's okay. And then I submit, and then that's it. Q2. Q3, count good nodes in binary tree. So this one, given a node, it's only good if there are no nodes. I think I took a little bit time of reading this one when in this contest. So there's a little bit of just reading. At this point, I was, yeah, just still reading. I think I was confused what X is. Um, and that's pretty much what I was doing. And I was like, what is X? Just rereading this form a couple of times, I think, actually. What is X? still double checking, but I was just like, okay. At this point, I knew that it was there for search, and I just wanted to make sure what the criteria is and whether you do the tree recursively, or you do the tree recursively, but whether you keep going or something like that. Like if a node is not good, can its children be good? And that's where what I think about here at this point as well. I was like, oh wait, do I just return early or something like that? I was like, no, you just count. Though it seems a little bit weird, and I was yeah, and I was like, wait, that's not right. It could have a children that is good. So yeah, so I was like, okay, actually, yeah, it was a little bit odd to think about. But then I do that for keeping track. And then that's pretty much it. And then I do a recursion and I have to check the base case of if node is none, then we don't keep going. But otherwise, you do node.left, and then the max of because the current max that you put it in is to check all the children or all the descendants even have to be bigger than that node value. So that's the recursive function that I have, and then I just kick off the tree, and that's pretty much it. And at this point, I was like, oh wait, there's negative. Each node could be negative, so I have to choose a bigger negative infinite number. So I'm glad that I did, because it would have cost me 5 minutes. But yeah, as you can tell, pending test is a little bit slow right here, which is a little bit unfortunate, actually. So I was kind of reading this one, but I wasn't focused on it, to be honest. And yeah, and it looks good. I hit submit, and then in theory, some people are really good enough to already focus on the next one. I'm not I'm not that good at switching back and forth. So even though I tried to start looking at this one, I didn't like none of it read. I was still focused on this one, so I was like, okay, you're not going to read it then, okay. And as soon as it accepted, I move on. And Q4, form largest integer with digits that add up to target. So this one I knew right off the bat after reading a little bit that it was just dynamic programming. I could keep track of the max, and generally speaking, I would in a general sense, you would probably use a path reconstruction to keep track of the last digit that you use at each node, and then go backwards to construct the path that you took. Yeah, and that's what I was thinking about. But I was like, there's only 5,000 digits. Python is pretty fast. Let me just use big int in Python numbers because it's only 5,000 digits, but it's only 500 integers or something like that. So I was kind of risking it, to be honest. But I knew that I was also right now at this moment pretty fast. So I was like, let's give it a go, and then let's risk it for maybe a good finish in terms of not doing the path reconstruction and just do it forwards and store it on each node. And that's pretty much all I needed to get started. This is a relatively standard dynamic program problem, and the idea is that for the recursion is that for each target, it is just the max of taking each of those digits, one of those digits, and then adding it to the or subtracting it from the target, depending on which direction you go, I guess. But that's pretty much it. Yeah, and I think I'm still a little bit thinking a little bit on whether this is fast enough at this point. But yeah, but now this is actually pretty straightforward dynamic programming. And honestly, even though I got this in about 8 minutes, I should have gotten it faster. Even not counting the mistake that you'll see me do pretty soon. Yeah, it's been a while since I wrote this dynamic programming, I guess. So I've been a little bit slow, but I really should have gotten this faster considering I didn't have to do path reconstruction, which everyone else probably did. But I was here, I was thinking whether it should be 9 or 10, and I was like, I don't know. But I was like, yeah, this code doesn't really make sense, but I think I was focused a lot on the recursion, and not the. I mean, for the most part, to be honest, during this problem, I was just worried about the running time, and that caused the penalty that you see. And it was just a big lapse because it's not a hard thing. And I think for me, the biggest problem for this problem was the running time. So I was like, okay, let's see how long it takes for the worst case, and this should be the worst case. Um, but yeah, and I think because of this, I did not. But this is just so silly. I should have gotten this. But yeah, I counted the 9 ones. I won code. So right now, my focus was just on running time for some reason, like for the reason that makes sense. And then as soon as I looked at the answer, I was like, I only looked at the last output, and then I was like, oh wait, that is not right. This is this plus 4. Yeah, still not right, clearly. So definitely just wasn't practiced enough, I think. This is pretty straightforward for a lot of, for someone who is practiced, this should be a 5-minute problem, especially if I don't have to do the path reconstruction. But I think I've definitely rushed it a little bit, even if it doesn't seem like it. And yeah, and at this point, I think the pending test also kind of got me a little bit because it kind of threw me off. And as soon as I saw the last answer, I was like, oh, that's good. Let me submit. I was going to do something about to check the length, but I was like, yeah, okay, let's go. That should be okay. Whatever, let's just submit. And then as soon as I hit that, I was like, oh no, wait, I didn't look at the other answers. Um, and I was like, oh, what silly mistake.
I made a mistake.
Yeah, and that was like the first test case. So like, really should have gotten that one, especially since, yeah, I would have been second in this contest. So that's not that's terrible. It's really not clutch. And I was like, oh, yeah, it's just that for this one. So what happened was that I didn't keep track of the fact that that. So basically, what happened was that I did target or less than target instead of target strictly, and that's the difference. And also, I think I didn't handle well. I think I handled the not visitable, but also have a typo here. But that's pretty much the only thing is that I did less than or equal to target instead of
was focused
exactly
on
target because I didn't keep track of one other thing for the dynamic programming. And that cost me, from whatever, drop from second place to what you'll find out later at the end of the video, because I don't think it's finished updating anyway. But yeah, but thanks for watching. I pretty much that's all. I refreshed. I was like, oh, only one person finished. So I actually had time for this, and it's still rating pending. So the system testing was also a little bit slow. I double checked the answer this time, and then that's it. Hang out the other Larry. Bye bye. Silly. Still would not have been first, but would have been, I guess, second. I would have, or third. I don't know. Would have been second if I wasn't so silly. I mean, I know that all the good people are doing Google Code Jam, but or at least a lot of the good people, but still, uh, that was such a silly mistake. I just didn't look at the answer. I mean, I didn't look at the system test because I watched it because I knew I was easy, or like I knew I had it, but then I just didn't look at the system test results because I was focused on the running time because that was the only thing that I was worried about. Um, let's see where I finish. Should have been second, but now we'll see. We have 3-4 minutes of people can only pass me, and I'm agonizingly. Uh, uh, sorry, this is live, so you're watching me taping this live, so I'm just like still processing and still um, just relaxing a little bit. I mean, see, there you go. I should have been second, but I made a silly mistake. The silly mistake of not. I mean, I tested, but then I just didn't look at the test. And I think as soon as I hit submit, I knew that I was like, wait, I didn't actually look at the results. And there you go. Okay, let's go over the contest. So I did very well in this one, regardless of that silly mistake that I really should have been second, but but nonetheless, and I should have done that faster in either case because I mean I think near the end the pending test was also a little bit slow, so that was probably why. But cool. Consecutive characters. Okay, sorry, let me calm down a little bit. That was too exciting for me. Oh, what a silly mistake. Oh well, it's okay. Uh, while all the people are doing Google Code Jam and I'm like doing this, that's why this is probably my best chance at whatever. But still, five. Oh, okay. I guess the numbers. Okay. Sorry. If you're watching this on the YouTubes, give me a second and just I'm still processing a little bit of how. What a silly mistake. Okay. Whew. All right. Let me go over the problems now. Consecutive characters. Consecutive characters. Yeah, for this one, it's pretty straightforward. It's just counting how many consecutive characters or the max number of consecutive characters. You could do this in a number of ways, but as long as you keep it in linear, and you don't even have to keep it in linear, it seems like. Just check to see how many adjacent characters are together, and there you go. I'm going to take the max of that, and yeah, and this is my code. I did in a couple of, not that many lines. The zip basically allows me to count consecutive characters, and I've actually done similar problems enough times that for whatever reason that I was pretty confident about this one. So yeah. So yeah, this is pretty straightforward, I think. Whew. Simplified fractions. So basically, you're given a numerator and denominator for this one, and there's only simplified if this GCD is equal to 1, meaning that the greatest common denominator between the numerator and the denominator is 1. That means you can't simplify it anymore. So basically what I did was I just did the brute force since n is only 100. Just check every x is equal to y or x is less than y and check that the GCD is less than or is equal to 1, sorry. And then that's it. And I just put it in, and I also checked that it could be in any order so we don't have to do any sorting. So I just return it afterwards. Cool. Count good nodes in binary tree. So this one, this is actually a funky way of putting it. Basically, there are no nodes with value greater than x. So basically, we just, for each node, we keep track of the max node or maximum value of the nodes on the way to that tree or to that node, and then check whether that node is bigger than it. so the recursion is pretty straightforward. The thing to check about is that there are negative values that might be a good 5 minute gotcha if you don't pay attention to that. But so I had to change my signal value to a big negative number. But after that, and there at least one node. So after that, I just do recursion, and again, if the node value is bigger than the max value, which is v, then I increment. And then we just do that recursively with the max value seen so far. And that's Q3. Cool. Q4. Give me a second. Let me refresh real quick. 9. Oh. Ah. Yeah, sorry. Just processing a little bit again. Okay, I mean, top 10 is still not bad. But yeah, wish I didn't have that 5 minute penalty. Then I would have been second, and that would have been, well, obviously just really cool. That was a really silly mistake. Yeah. Okay, Q4. Q4, form largest integer with digits that add up to target. So I think the intended solution for this one, to be honest, is dynamic programming with construction, with path reconstruction. I did not do it that way. And that's why I was rushing it. I took a little bit of a gamble to save time, but then because the thing that I worried most with the way I did it. So basically, what I took advantage of is that in Python, these numbers convert directly to big int or big numbers. So that's what I did, and because they could be at most 5,000 digits. So that's why I had that case where I had a test case where it was just everything is cost 1. And because I was and 5,000 digits, and because I was so fixated, because I was so like worried about the running time, that I didn't look at the result. I didn't look at the answer, and I here I did this instead of that. I think as a result, and or something like that. I don't remember what I did, but it was some really silly thing where. Yeah, but the idea is that this is dynamic programming, and the recursion is the cost of each digit. So this is your cost target, and then each of these costs you just go backwards, counting what's the biggest number that you can get. If you have to do path construction, I would have to do some tracking. I would have to check. I would have to track which digit was the prior digit that we added for this one, and then we do a path reconstruction. But I didn't have to do that because I was gambling a little bit on running time. That's why I did what I did. But then I rushed it because I was just so excited about getting it right, or getting the running time to be fast enough, that I submitted a little bit prematurely without looking at the test. And as soon as I submit, I'm like, wait, I didn't actually look at the test because I was so excited that, when I saw the test, I was like, oh, this is obvious. And like obvious that it was incorrect, and also obvious to fix, because I knew how to fix. Well, I knew how to solve the problem in general. It's just that I rushed it a bit. So, and because I was really thinking that I had a good chance of placing really highly. So yeah, that's all I have for this problem. But yeah, if you have trouble with this is actually relatively straightforward in terms of dynamic programming. The only tough part is the path reconstruction part. And I urge that you just take a look at the path reconstruction at somewhere, and you could, figure out how to get the prior digit one digit at a time, and that's how you get the path reconstruction. So yeah, so overall, an easy contest. So overall, I should have been second, but what can I say? I rushed it. And this is the difference between 5 minutes, right? Is that there are a lot of pure can happen in 5 minutes, and I watched it, and my most, that would have been my one chance to get a high score. And oh well, it's okay. I mean, I finished top 10, which is something that if you told me beforehand that I finished top 10, I've been really happy about. Um, and that's all I have for this contest. Yeah, thanks for watching, Wench, for your support, and thanks for your good luck. I will see you next contest. Bye bye.